All right, talking about telescopes. Suppose you're a spy on a dark street hoping to spot another spy. How would you see the other spy in the dark? Wear a pair of infrared goggles. All objects give off radiation that you can't see. The glowing coals of an electric heater give off infrared radiation, which you feel as heat. Human beings also glow infrared, and with the infrared goggles you can see a green outline of a person in the dark. Some objects in space also give off invisible radiation that we can detect with special telescopes. So answer this question. In what other situations might you want to use infrared goggles? Okay, what are the regions of the electromagnetic spectrum? This should be kind of a review since we've learned this. To understand how telescopes work, it's useful to understand electromagnetic radiation, or energy that can travel through space in the form of waves. Scientists call the light we can see visible light. Visible light is just one of many types of electromagnetic radiation. Many objects give off radiation that you can't see. Objects in space give off all types of electromagnetic radiation. All right. The distance between the crest of one wave and the crest of the next wave is called the wavelength. Visible light has very short wavelengths, less than 1/1,000,000th of a meter. There are some electromagnetic waves that have even shorter wavelengths. Other waves have much longer wavelengths, even several meters long. If you shine white light through a prism, the light spreads out to make a range of different colors with different wavelengths, called a spectrum. The spectrum of visible light is made of the colors red, orange, yellow, green, blue, and violet. The electromagnetic spectrum includes the entire range of radio waves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. An object looks different depending on the type of electromagnetic radiation striking it. Scientists use different wavelengths of the electromagnetic spectrum to learn about distances and properties of components in the universe. For example, visible light is used to calculate distances to stars using parallax, the apparent change in an object's position when viewed from different places. All right, so the electromagnetic spectrum. Humans see visible light, but bees can see ultraviolet light, so flowers look different to a bee. What advantages does having ultraviolet vision give bees? So look at these two flowers. This is visible light, this is ultraviolet radiation, UV. How would that help bees? All right, what are telescopes and how do they work? On a clear night, your eyes can see at most a few thousand stars, but with a telescope, you can see many millions. Why? The light from stars spreads out as it moves through space, and your eyes are too small to gather much light. Telescopes are instruments that collect and focus light and other forms of electromagnetic radiation. Telescopes make distant objects appear larger and brighter. A telescope that uses lenses or mirrors to collect and focus visible light is called an optical telescope. There are also non-optical telescopes. These telescopes collect and focus different types of electromagnetic radiation, just as optical telescopes collect visible light. All right, optical telescopes. The two major types of optical telescopes are refracting telescopes and reflecting telescopes. Over here at this vocabulary, it wants you to complete the sentence by circling the correct words. An optical device may use many different kinds of optics or optical, including mirrors and lenses. So just getting you comfortable with this word optical and what it means. All right, you have two different types. Refracting telescopes. It is a telescope that uses convex lenses to gather and focus light. A convex lens is a piece of glass that is curved so the middle is thicker than the edges. A simple refracting telescope has two convex lenses, one at each end of a long tube. Light enters the telescope through the large objective lens at the top. The objective lens focuses the light at a certain distance from the lens. This distance is the focal length of the lens. A larger objective lens means that the telescope can collect more light. This makes it easier for astronomers to see faint objects or objects that are far away. The smaller lens at the lower end of a refracting telescope is the eyepiece lens. The eyepiece lens magnifies the image produced by the objective lens. A magnified image can be easier to study. All right, and then over here we have reflecting telescopes. In 1668, Isaac Newton built the first reflecting telescope. A reflecting telescope uses a curved mirror to collect and focus light. Like the objective lens in a refracting telescope, the curved mirror in a reflecting telescope focuses a large amount of light onto a small area. A larger mirror means that the telescope can collect more light. The largest optical telescopes today are all reflecting telescopes. Why are the largest optical telescopes reflecting telescopes? Because the mirror can be supported from below, but the lens of a refracting telescope must be supported from the edges so light can pass through it. All right, figure 2. Refracting and reflecting telescopes. A refracting telescope uses a convex lens to focus light. A reflecting telescope uses a curved mirror to focus light. After reading about the two, circle the correct answers in the table showing the similarities and differences between them. Okay? So you go through here. If we're talking about refracting, is the objective a lens or mirror? Eyepiece, lens or mirror? Typical size, smaller or larger? Light collection, less or more? And you circle the word that is going to match it. All right, figure 3. The Hubble Space Telescope. The Hubble telescope is a reflecting telescope with a mirror 2.4 meters in diameter. The Hubble telescope orbits Earth above the atmosphere. As a result, it produces very detailed images in visible light. It also collects ultraviolet and infrared radiation. Images such as the one shown here have changed the way astronomers view the universe. All right, did you know? Astronomers are concerned about light pollution, artificial lighting that makes it hard to see the skies at night. Some cities have replaced their street lamps with ones that point down. With these lamps, light isn't beamed into the night sky and people can once again see the stars. All right, other telescopes. Telescopes are usually located in observatories. An observatory is a building that contains one or more telescopes. Many large observatories are located on the tops of mountains or in space. Why? Earth's atmosphere makes objects in space look blurry. The sky on some mountaintops is clearer than at sea level and is not brightened by city lights. Radio telescopes. They detect radio waves from objects in space. Most radio telescopes have curved, reflecting surfaces. These surfaces focus faint radio waves the way the mirror in a reflecting telescope focuses light waves. Radio telescopes need to be large to collect and focus more radio waves because radio waves have long wavelengths. Some radio telescopes, like the one in Figure 4, are placed in valleys. The Spitzer Space Telescope, launched in 2003, produces images in the infrared portion of the spectrum. Very hot objects in space give off X-rays. The Chandra X-ray Observatory produces images in the X-ray portion of the spectrum. X-rays are blocked by Earth's atmosphere, so this telescope is located in outer space. Some new telescopes are equipped with computer systems that correct images for problems such as telescope movement and changes in air temperature or mirror shape. Okay? All right. The Arecibo Radio Telescope in Puerto Rico is 305 meters in diameter. Why are radio telescopes so large? It explained that right up here. All right, apply it. On the diagram, identify where the following kinds of telescopes work best and explain why. Place an X where you would not put a telescope. All right, and then assess your understanding. Which wavelengths of the electromagnetic spectrum do the tools of astronomers use to gain information about the components of the universe? Okay, and then B. A student of astronomy suggests locating a radio telescope near a radio station. Is this a good idea? Why or why not?